Rekao sam na početku da su dva glavna internet protokola rutiranje i DNS. Tako da u ovom bloku ćemo čuti koje novosti vezane za DNS imamo i koje su najnovije opasnosti. I sada će nam se obratiti David Huberman iz ICANN-a i govorit će o bezbednostnim problemima koje donosi kripto zaštita DNS-a, to jest DNS over TLS i DNS over HTTPS.
Hey, thank you, Zarko. Hello, everybody. I don't speak any Serbian, so I'm going to speak in English. So I want to talk today about the biggest issue that's been going on in DNS throughout 2019, and that's about applications doing their own DNS. In the traditional model of DNS, DNS is 34 years old now, and for 34 years we've been pretty much doing the same thing. We've been sending clear text queries, primarily over UDP, in a resolution model that stayed pretty much static until recently. As a user with a device, your stub resolver sitting on your device connects to a recursive resolver that gets the answers that you need. Thank you. And those recursive resolvers are what we're going to primarily talk about today. These are typically run by your ISP, or if you're at a university as a student or staff, the university is running the recursive resolver. If you're in a company, especially in a large one, the enterprise is running the recursive resolver. And this works. It's worked for 34 years. It's worked for a number of reasons, but some of the things that this model meets well are things like regulatory compliance. Governments need information sometimes. Police need information sometimes. And they're able to get what they need from recursive resolver operators fairly easily. There are governments in this world that restrict DNS queries. Certain words you can't use in certain countries that they either tell the recursive resolver operator to block or to change, redirect it, or sometimes they don't do any of that. They just say, we just want you to log those queries for those certain words. And the government requires this, so they do it. And it works. It works fine. Our service providers also often want to protect us. They want to protect us from going to sites we shouldn't be going to. They put types of malware protection, and they do it in the DNS. It's the easiest place to do it. This whole thing works in public DNS. Over the last number of years, recursive resolution has moved slowly away from this traditional service provider model into a central DNS model. We have all these quads, Quad 8, Quad 1, Quad 9. In Taiwan, it's Quad 101. And there's many, many others. There are hundreds of public DNS operators. This model works. It turns out governments can still serve legal process on public DNS operators, and they abide by it. Malware protection. Well, we're going to hear in a little bit from Quad 9. John Todd is here to talk about us, Quad 9. Malware protection is actually a value offering for Quad 9. They purposely block sites so that you can't go there when you set it as your recursive resolver, and this is a good thing. But this entire model has a little bit of a security concern. We're sending queries over clear text. Anyone listening on the wire, anyone doing any type of passive monitoring can see not just the queries that we make. Hey, I want to go to www.foo. Well, they not only see that me, David, went to www.foo on such a time and such a date, but they're also getting my metadata. They're seeing information about my computers, about my devices, about things that are connected to my search. Now, a lot of end users who are looking for more privacy say, you know what? I can buy myself a lot of privacy if I just tunnel everything through an encrypted VPN. If I use a VPN, the bad guys or the government or whoever can't see what I'm doing. The problem is VPNs only encrypt the channels they choose to encrypt. And if you look at popular VPN products, one of the channels that's often unencrypted is port 53. So there's a tremendous amount of data leaking out of VPN sometimes, and the DNS data critically can leak out of certain VPN products. So one takeaway, if you like to use a VPN, please take a moment tomorrow and make sure that the VPN product you're using is actually encrypting port 53. And the point here is that it's the DNS queries that come from our devices on our stub resolvers to the recursive resolvers that are the most vulnerable to intercept. They're the most vulnerable to us losing our privacy. So there's a pretty obvious solution to this, and that's to encrypt. So over the last few years, the IETF has standardized two encryption technologies for DNS. DNS over TLS, DOT, and DNS over HTTPS, DoH. DoT is a really simple design. It takes advantage of TLS to encrypt the transport channel between the stub resolver and the recursive resolver. Nicely, it's built to run on port 853. It's got its own port instead of port 53. This is really good for service providers because anyone who's operating the network, you can see the traffic and you can deal with it however you want because it has its own port. DoT is usable by pretty much any application because almost every application today uses TLS. The biggest implementation I know of DoT is Android. Android 9 and now Android 10. They don't have it on by default, but it's an option. You can set it up in your network stack to use DNS over TLS to a TLS resolver. And then there's DoH, and that's really what we're going to be talking about for the next 15 minutes. And what I want to do is, just for a moment, I want to separate what the goal of DoH was when they designed the protocol versus how it's been implemented. From a protocol standpoint, DoH is actually quite good. The whole purpose of it is to figure out who do you trust. So I run my family's finances. I take all of our money and I have to manage it. So I put the money in a bank. And I chose a bank in Canada that I really like. So I put all of my family's money into that bank. Because I trust them. I've chosen to trust them. Not only do I trust that bank to hold my family's money, I trust them so much that I get on my phone or my computer and I actually do digital banking with them. And that's kind of a dumb thing to do if you think about it, because our connections really aren't all that secure. But I trust them enough that I'll go ahead and do online banking with them and trust them. If something happens, if somebody somehow captures my login credentials and they try and take my money, that the bank will make good at it and put the money back. So if I trust this company, this bank in Canada, to put all my family's money into it, and if I trust them enough to do digital banking with them, maybe it's the bank I should trust to do recursive resolution for me. Maybe if the bank sets up a DNS server and I use them for recursives, I can trust that they're not going to do anything with it, that information, the query data and the metadata, that I don't want them to. And that's the design of DoH. The design of DoH is to give end users privacy for their DNS data, privacy we've never had before. Unlike DoT, it doesn't have its own port. DoH runs on 443. 443 is where all of the HTTPS traffic goes. It's completely commingled, and you can't figure out what is the DNS part of it and what is just the regular 443 HTTPS traffic. That's by design, by the way. So the very first wide-scale implementation of DoH is Mozilla Firefox. And at the beginning of the year, or maybe it was the end of last year, they started describing how they were going to implement it. And the whole world freaked out. And it freaked out because it took away a lot of controls that service providers have and rely on to protect users and to run their network. You couldn't use the DNS anymore to comply with regulatory requirements. You couldn't use the DNS to do malware protection. And interestingly, as the service provider, you provide support for your users. Well, if a DoH resolver that Firefox has said you're going to use as a Firefox user, if it stops working, you're a regular end user, you're typing in www.whatever and nothing happens, it turns out you just assume your internet's broken. So you call your ISP. And you call your ISP and say, hey, the internet's broken. Can you fix my internet? Can you send somebody out? But they didn't break anything. Their service works fine. The problem is you're using a resolver that they don't have any control over, and they can't even see the queries that you're doing. Now, the DoH people say that's actually a feature, not a bug. But from a service provider perspective, that's actually a bad thing. The other thing we've learned this year is that ISPs do a lot of business on parental controls. Parental controls is actually a pretty big thing for them. And the easiest way to implement parental controls is in the DNS. But if your users aren't pointing to your recursive resolver anymore, those parental controls don't work. I also put under here, the ISPs often receive court orders to block certain sites, as we've discussed, and they can't do that in a DoH world. If we step back from the service provider for a moment, we do have a little bit of public policy concerns here. If you set your resolver to 9.9.9.9, where is that resolver located? The one that you're using. Is it here in Belgrade? Is it here in the Republic of Serbia? Is it in Eastern Europe, Southeastern Europe? Is it in Europe at all? Law enforcement, prosecutors have some concerns here, because when incidents happen and digital investigations have to occur, we've got multiple jurisdictions going on. And this is different than it's been in the past, because in the past, traditionally, when an end user does a DNS query, the recursive resolver that is used to capture that query and provide the answer to it typically has been located in the same country. Typically, it's located in the same AS, because typically it's run by the service provider. Who gets to choose your resolver? Well, the whole point of ADD is you. The whole point is that the end user is supposed to say, this is who I trust the most. I trust my bank, so let me use my bank's DoH resolver. That's the whole point of DoH. But the problem is, not everybody's honest. What happens when the application maker, think about an application on your phone, think about a browser application, think about an operating system. If they're using DoH and they choose the DoH resolver for you, have you really gotten any choice? Are you getting the privacy that you've requested? What if the application maker is not honest? What if they're using a resolver that steers queries away from where you're intending to go and instead sends them somewhere else? What if it's monetizing your data and doing so, of course, without your consent? They didn't ask you, hey, can we make money off your DNS data? Bad or dishonest implementations of DNS over HTTPS or DNS over TLS, these can actually disempower end users. And it's a problem because it disempowers end users in a context that none of them understand, which is DNS resolution. We in this room understand DNS resolution. Nobody else in the rest of the city really understands it. We have 3 big implementations today of DoH. The first one is Mozilla Firefox. It's done some fine-tuning over the year. Under the current rules of Firefox, DoH is on by default. This is part of their value add. If you use Firefox, guess what? We're going to protect you from the big bad ISPs that are monetizing your data. However, they've adjusted to some of the lessons we've learned earlier this year, and they said, look, we're going to do some auto detection, and if we figure out that organizations have their own policies, or if users, you have your own settings that you want, you can use the configuration to disable DoH when it interferes with your preferred policy. This fall, Google has started to roll out DoH. They do so very innocently. They simply do a check. Does the resolver that's in your network stack right now support DoH? If it does, it automatically points to the DoH resolver for that organization who you've chosen. And earlier this week, Microsoft has announced its implementation of DoH for Windows. And similar to how Google does it, they're also going to do some auto detect to see if the user's resolver supports DoH. Interestingly, of course, it's an operating system, so it's implementing DoH at the operating system level. So one of the unintended side effects of applications doing their own DNS is this fear or this reality, depends on your point of view, that this is going to increase resolver centrality. The number of recursive resolvers in the world that are popularly used continues to shrink. More queries go to less number of recursive resolvers. So our friends at APNIC were studying this year, and they asked themselves a question. How many resolvers would it take to cover 50% of all queries that we can measure? How you measure, by the way, really counts. Measuring this stuff is hard. They did their measurements, and they found it only took about 8 or 9. And by far, the dominant recursive resolver in their studies was Google's 8.8.8.8. There were also some other big resolvers. Not surprisingly, most of them were in China and the United States. During conversations about applications doing their own DNS, Joe Abley, the Chief Technology Officer of PIR, which runs .org, he said, hey, look, I took a look in my authoritative server logs, and I found for the entire .org domain that 24 resolver systems are responsible for 80% of all the queries for .org. That's a lot of centralized recursive service. He looked at Google and he said somewhere between 15 and 20% of all the queries to .org go through 8.8.8.8. So look, public DNS, centralized DNS, can be a very, very good thing. It depends on who you are and it depends on where you are. We're network operators here. Think about when you're building internet. You are concentrating on what? Building out fiber. You're spending a lot of your time dealing with interconnect. You want better transit and better peering. You are worried about service operations. Do I have frontline support for my users? You're worried about organizational matters. Oh, and by the way, you got to sell this thing too, right? It's a lot of time and a lot of work to run an ISP or to run any service provider. What public DNS does that's really nice for the service providers, especially smaller ones or ones in developing nations, is it takes them having to worry about recursive resolution out of the equation. You simply point your users to 9.9.9.9. You point your users to 1.1.1.1. You point your users to somewhere where someone's already built out an infrastructure for you, already has the expertise to make it fast, and it costs you no money. Because you're not going to make any money off this stuff. It's just a cost center for you. So public DNS is really, really good, especially in developing nations. The problem, though, is we have a larger number of queries going to a smaller number of players. And that prompts quite a few concerns. One of them is it gives them a lot of power. I work for ICANN. We spend a whole lot of time trying to evangelize and popularize DNSSEC. One of the biggest allies we've had in rolling out DNSSEC is Google. Google's been highly, highly supportive of DNSSEC. Well, what happens if they change their mind? What happens if they turn DNSSEC validation for some reason off on 8.8.8.8? The statistics go plummeting. The amount of DNSSEC validation that's possible goes down. Over-centralized recursive service prompts other questions. Content filtering. You know, in the social media world, they've worked really hard, or they've struggled, I should say, with filtering. Twitter comes out a few weeks ago and says, we're not going to allow political ads anymore. Well, in order to do that, they've got to figure out filters for that. And it's actually kind of hard, and arguably, they've not done a very good job of that. But compared to DNS, Twitter's nothing. There are trillions and trillions of queries every single day in the DNS. And if more and more of these queries go to a smaller number of players, and these players start to do content filtering on that, that's a whole lot more impactful than a social media company trying to do content filtering. The internet works. The internet has worked over the last 40 years because we've built it cooperatively. We use the IANN namespace, generally. We use and we buy into the IANN number space. We've set up a bottoms-up, multi-stakeholder model where we're actually empowered as network operators to make sure this thing runs properly. Because if it doesn't run properly, we can change it. It's not top-down, it's bottoms-up. But when you have more and more recursive service in the hands of smaller and smaller players, you can lose this. This is at risk. Two more quick things. The whole goal of applications doing their own DNS, the whole goal of encrypting the transport channel is to give end users privacy. But if we want to give them privacy, why are we redirecting more and more queries to a smaller number of players? And many of these players, by the way, are in jurisdictions that don't have strong end user privacy regulations. 8.8.8.8, the most popular DNS service in the world, is run by a company housed in the United States. If the US government decides something's going to happen, that's going to happen. The US law doesn't have strong end user data regulations. Yet we're putting more and more and more of our end user data into 8.8.8.8. Oops. So, final thoughts. This thing's very new, okay? DoH only became a protocol a year ago last month. It's 13 months old. That's not very old. That's not very old for a technology. So this is new. We're learning. One of the things we're learning is that implementation details matter. The DoH implementation that Firefox announced a year ago is a whole lot different than what they announced today. DNS privacy is something we figured out as a community we want. It's something end users want, and it's something regulators have decided they want. So encrypting DNS data with TLS, encrypting it in HTTPS, moving to new things like DNS over quick, these are all good. These are all good for society. These are good for the internet. But how you do it matters. So that's applications doing their own DNS. That's DOT and DOH. If you have any questions. Okay, we have a couple questions from the audience. We're just waiting for the microphones.
Hello. Okay, so I'm kind of confused by your presentation. Okay. At one level, you're saying that we're giving DNS control to smaller governments, smaller ISPs, decentralization, and at one point you say that's bad because governments don't have maybe data privacy laws, etc., etc., etc. Then at second point, you say that Google is the largest DNS provider, and then again you say that it's US-based, and because United States can enforce some laws, scrub the site of the internet. So I'm confused there. Are you pro-decentralization or against decentralization?
I'm not pro or against it. I'm not here to advocate for it or against it. What I'm saying is that we've decided as an internet community that it's probably a good idea to encrypt this channel between the device and the recursive resolvers. And this is probably a good thing. I hope everyone thinks this is a good thing.
It is.
Yeah. The problem is the unintended consequences, where what we have is the reality of public DNS that is a centralized thing. It's good in some contexts. It's really good in developing nations. It's really good in Africa, okay? It's bad in other ways. It's bad. It's like counterproductive to say, we all believe this is good to encrypt the transport channel. But if it has the consequence of moving more and more and more things into resolvers that are in countries that don't have good end user data privacy regulations, well, maybe that's not so good. It's not a binary thing here. It's complex. And as operators, as protocol developers, as internet users, and as decision makers, we have to consider all of this when we think about how we want to build our networks, how we want to build our services in the way that's best for our users and best for the internet. I don't have an answer for you because I'm not trying to answer that question. I'm just saying this is hard. What's cool is that we've changed our mind in just a year. A year ago, Firefox, the very first to the market on DoH, said everyone's going to use DoH and this is how you're going to use it. And then a couple of people said, no, wait, I've got a problem with that. And so they fixed it. And so it's something that we're going to learn as we go. And my point of standing up here is not to tell you where we should go, it's just to talk about what we need to think about as we're getting there. That's all.
So in some, I don't know, scenario, we could say that the long run solution or goal should be DoH implementation across the board, and then we can talk about centralization and decentralization.
Yeah, whether it's DOT, whether it's DOH, one of the new protocols that's going to come out of the IETF is DNS over QUIC. Whatever it is that we have that provides better privacy, this is probably a good thing. And then what we do with that is figure out what are the unintended consequences and how can we make them better. Because that's what we do. That's what we do. You think about transit and peering 10 years ago. You think about transit and peering 20 years ago. We did it completely differently than we do today because we figured out better ways to engineer it. One of the other goals of my talk that probably doesn't really come through well in the slides is that it's better if we fix it. It's better if we as network operators, and for those of us in the audience who work on protocol engineering, it's better if we fix it and not make it, and any screw-ups we have, it's better if we fix it now because the governments are more and more interested in fixing it themselves, and that's really bad for technology. So, okay, we have another question here.
So you said about, sorry, about using it in a small Africa state. So, so we can use it something like universal service, like universal phone or internet service, like only for the pure part. So not to use it in emerging markets on the markets that are now bigger. Like because the industry started with destroying incumbents. So ex-ante regulation put this industry, and we are now on the other side, because now the industry that started is making like the biggest monopoly, bigger monopoly that incumbent providers were on in 90s maybe.
So my point about where public DNS is good in developing countries is more just about thinking about what it takes to operate a network. In order to set up your own recursive resolution for all your users, you've got a lot that you've got to know. And especially in a developing nation, you may not have a lot of staff. And where you have to spend that staff's time is on building the things that actually sustain the network and in some cases help you make money. DNS doesn't help you generally, it's not supposed to anyway. DNS is not there for you to make money. DNS is supposed to be a core service. But in 2019, DNS is a whole lot more complex than it used to be. There are 250 or so RFCs covering 2,500 pages of material about the DNS protocol now. So it's a lot harder, and it's a specialty now. So the only point I was trying to make was that public DNS is really good in those circumstances because you can just point your end users to 9.9.9.9, and it works. It works well for them, it works quickly for them, and it costs you no money. You're right. We did start off the internet with a whole bunch of incumbent carriers, and we've broken those up nicely. National telcos, well, they're still a thing in some countries. They're not a thing in most countries anymore. Not like they used to be. And this is a good thing. It's a good thing for consumer choice. But public DNS and these types of things really do have a place.
Oh. One question, please.
So, Zoran from Program Committee. Both Žarko, myself, and Nenad tried really hard to bring relevant people to discuss this issue of privacy. Eventually, Google did not come. We contacted them. We contacted the right people. Okay, it was a short notice. And they reacted like, oh, sorry, you should have called us 3 months earlier. But eventually, Cloudflare is here, Quad 9 is here, but Google is not here. And they are the biggest. So that leaves me to a question. DoH, DoT is a transport protocol.
Yes.
Who do we trust to do the resolving? How can we, the DNS operator, it's just a transport protocol, yeah. But then do we trust Cloudflare? Do we trust Quad 9? Do we trust the incumbent? Do we trust China Telecom? It is a question of trust. And how we are going to establish that trust? That is my question.
Yeah. You're asking me an impossible question, of course, because most end users don't know what we're talking about. My friend in the back, whose name I'm sorry I don't know, my friend in the back made a really interesting point during the coffee break. End users don't care. End users just want it to work. They don't know what DNS resolution is. They don't know what UDP and TCP are. They don't know what QUIC is. They have no idea what Quad 9 is. They have heard of Google, and a scary number of them have heard of 8.8.8.8, okay? Who do you trust? Look, we're very smart men and women in this room. You have to make that, we all have to make that decision ourselves. We have to make the decision on our home computers for ourselves, for our families, for our children. But you know what? I've been doing this for 21 years. This is my iPhone. Do you know what I can't do on my iPhone? Set my recursive resolver. It's not a feature. Nowhere for the Android users, you're looking at me like, what? Yeah, switch to Android. But I like the iPhone. It's got the games I want. But that's how it works, right? I'm a smart internet engineer. I choose to use a device that I cannot choose the recursive resolver. So what I guess is my answer to your question is presently I'm trusting, well, I'm on the Wi-Fi, so that's not working. MTS. I'm choosing MTS. So MTS, thank you. Okay. All right, that's it for me. Thank you very much.
Okay, thank you, David. Can you sit closer? Yep. We heard, čuli smo veoma interesantnu priču o DoT-u i DoH-u i sada ćemo da nastavimo sa DNS-om. John Todd iz Quad 9 će nam reći o njihovim praktičnim iskustvima koje imaju u radu sa public DNS-om.
Thank you. Good afternoon. Thank you very much for having me, and I will also apologize for presenting in English, my only poorly spoken language. Can we bring up my deck? I am prepared for this. So I'm the executive director of Quad 9, so it is a very DNS-filled day here today, and I think we've got one more DNS presentation, and then hopefully a very good presentation or a roundtable on this. So the brief introduction of Quad 9. We were founded in 2016 as a not-for-profit organization with the intention of providing secure and private DNS services at high performance. So those are our three goals. It's security, privacy, and speed. So we were founded by a combination of several different organizations. Our primary sponsors are Packet Clearinghouse, who is another non-for-profit. We are located, as an example, in Packet Clearinghouse's facilities at the SOX. Thank you very much. So we do have facilities here. Our other sponsors were Global Cyber Alliance, who were chartered to help internet security. And then the last one is IBM. IBM helped us with getting the address space 9.9.9. So am I on? Am I good here? Okay, great. Awesome. We are a not-for-profit based in the US, so we take no money for our services. All of our services are absolutely free to anyone who wants to use them, whether you're an organization, an individual, a university, a municipal government. And then we provide DNS services over all of these standard protocols. So we support standard DNS, of course, and then DoH and DoT, as you've heard about. And I'm sure we'll talk more about some of these and the pluses and minuses in our panel. Also, like Google and like most of the other major resolvers like Cloudflare, we are now strictly validating DNSSEC on our primary addresses. So this is helping the security of the DNS by providing answers that are actually being generated by authoritative servers. And then the question of why is there why another recursive resolver? Again, the not-for-profit component is a major reason for why we exist. The primary recursive resolver operators are typically your ISP. They usually provide that at no cost, but the centralized systems, those are for-profit companies whose reasons for providing DNS are often, whether directly or indirectly, rooted in making money off of end users, and that is not our goal. We deploy our servers to a larger number of endpoints in the emerging world, so Africa, Southeastern Asia, Central Asia, and also to many of the IXs located worldwide. We are in 146 locations now, I think. I'll have a map of that in a few minutes. So why would you use Quad 9 versus your ISP? Quad 9 on its primary addresses, which are the ones that everyone remembers, which is 9.9.9.9, we operate a security service on that IP address. So it's a block list. If you're familiar with the term RPZ or RPZ, we collect threat information from a number of different providers, and we will block connections to malicious hosts. So malware distribution, botnets, phishing sites, DGA, etc. We also, as far as user privacy goes, we do not resell or retransmit that data. So providing user privacy is another reason that people will convert to Quad 9 for both their individual use as well as their organization. From a privacy and security perspective, we are located typically in IX locations with packet clearinghouse. So one of the components you get along with our not reselling IP addresses or not reselling user data is that Quad 9 is directly adjacent to about, I think it's 500 TLDs, including Serbia, as an example. So we are in the same rack, we're in the same space as those authoritative servers. So a lot of what the DNS leakage is that people are concerned about these days is leakage of DNS data back through all the way up to the roots, where people can analyze individual queries and try to determine what's being looked up. By using Quad 9, we reduce that risk. We do QName minimization, meaning that we don't actually send the entire name of the query all the way out to the recursive resolver, or sorry, the authoritative resolvers, except for the authoritative resolver that is directly responsible for that particular portion of the name. And again, because we're adjacent to so many top-level domains, the queries don't leave our rack in a large portion of the cases. So Quad 9 was designed to be adherent to GDPR regulations. The way that we solve this is different than a lot of other organizations that run recursive resolvers. We never store any information about end users in our platform at all. So this has actually been kind of a challenge for us in trying to get GDPR approval, because the answer of we don't store any PII is not a concept that they're familiar with. They're familiar with, okay, you store PII, but how do you store it, and what's the process you go about revealing it? Whereas our answer is we never store it. The only time that we have the IP address is the amount of time that it takes to collect the query and respond to it, and then we discard it. There are some exceptions for denial of service attacks, but that's also called out in the GDPR as being a legitimate thing to do. We actually don't want all of your queries. This is also unusual. There are companies these days that will actually pay ISPs for their DNS query stream. And that is for the purposes of both generating marketing information, sometimes it's generating security information. We actually don't want the entire query stream at all. We would prefer, if you're an ISP or if you're a university or even if you're a home user, that you run a small caching forwarding resolver in your network and you simply forward the first queries out to us. And then we'll tell you whether it's a malicious or not by answering with an NX domain or answering with an actual address. So we don't want to see every query from your internal users or your ISP users. We just want to see the first one so that we can give you the answer whether this is malicious or not malicious. This increases performance because your cache is typically inside your AS or even inside your local LAN. It improves user privacy because we don't see those end queries. And it also allows you as the operator then to add additional layers of policy on top of that. If you want to block on certain content, you're able to do that locally. If you want to run a DoH server inside your network, we encourage you to do that, but then forward the queries out to us on that first request. There are also some other things you can do if you run a recursive resolver or forwarding resolver inside your network, where you can actually have some load sharing and load shedding capabilities. So if you don't trust the centralized model where the one provider is your upstream, or one company as your upstream. You could configure it so that you actually shed that load or share the load across multiple providers. We're not interested in being or having all of your query data. There is Quad 9 actually offers several different flavors of service. The way we do it is that you can query different IP addresses on our network to get different results. The primary one that everyone remembers is 9.9.9.9. That kind of has all the full set of things that you want on it. It has DNSSEC, it has our block list, it has QName minimization. There are other IP addresses that you can use on our network that will give you more or less features. If you use 9.9.9.10, as an example, there's no DNSSEC on that. There's no block list on that. So that acts as a very dumb resolver, so you can look up things to see if they're being blocked by us or not. Or it's a test server. You get less security, but you get a more open resolution path. We also offer ECS, and this is relatively new. If you have a CDN provider that's inside of your ASN, some CDN providers use a feature in the DNS called ECS, or eDNS Client Subnet. It actually, we don't like ECS from a privacy perspective, because what ECS does is it includes the first 3 octets of your IPv4 address in the DNS query to the authoritative server, allowing the authoritative server to make a decision on what AS and what CDN server they're going to try to connect you to. If you have a CDN service like Akamai inside your network, ECS might be something you're interested in. We do offer that, again, on a different IP address, so 9.9.9.11. If you use that, you get DNSSEC, the block list, and ECS. So there are a variety of different things we have that we offer on the network as far as flavors. You can go to the Quad 9 website to get the full list and what the upside and downside is of each. ECS isn't great because we have to cache all of the additional data. So every user on your network, if they're in a different /24, as an example, may get a different DNS response back from the CDN provider. So instead of one answer being cached, you might have 20 answers that are being cached. And so that costs a lot more in memory. Therefore, we've had to, we say that ECS is going to typically give you slower responses because for the same cache size, the same memory footprint, we have fewer users that can fit into that effectively. Whether your end users notice the speed difference or not is a relative question. Most don't. In very, very large cities like London or Frankfurt, that actually might make a difference. Here in Serbia, I suspect it wouldn't make much of a difference at all. Most of those memory questions would be answered by the servers we have. So what isn't Quad 9 is actually just as important a question about what it is. Some of the things we don't do, we're not a complete security solution. The discussion from George about what Quad 9, what Cisco does, where they do evaluations and try to figure out all these different sites that are doing malware or they're doing phishing or doing homoglyphs. Quad 9 doesn't do that. What we do is we relay information from threat intelligence providers. We're essentially, if you want to think about it, as we are the electric lines, but we don't actually make the generator at one end and we don't make the light bulb at the other. We simply transmit the information from an existing set of threat intelligence providers. Right now we have 19 different threat intelligence providers that give us these lists of malware sites. We put it into our version of the DNS and then relay it to the end user. It's a very, very hard problem to solve. Building these malicious lists is an extremely difficult and precise science, and there's a lot of work that goes into that. And we have determined that the best way to do that is to combine the information from a number of different commercial and non-commercial sources into a single path. And I'm very interested to talk more in Cisco to see if we can include them in the near future as well. Some of our partners include ThreatStop, ThreatConnect, IBM, OpenFish. We've got, I think, 15 or 16 others that we combine the data from. So it is a blended threat list, which is actually in many cases at least as effective, if not more than effective, than some of the better single lists. We don't do content policing. We don't actually filter based on ideas. We only filter based on end user harm. So we don't do parental control. We don't do gambling filtering. So if an enterprise wants to do those things, again, we suggest that they put a resolver at the edge of their network, implement those things inside that resolver, and then forward us the queries. So we are strictly trying to prevent user harm, end user harm, and end network harm, not content filtering. We don't have, again, other things that we're not a CDN, we're not a marketing company. We have no other products. There's nothing we're trying to sell at the end of the day with Quad 9. We're trying to give away the service, so there is no hidden agenda that we have. There's no hidden for-profit motive that we have. It is entirely a not-for-profit enterprise. Also, some of the things you lose with Quad 9 because of our privacy constraints, there's no reporting. Quad 9 simply provides blocking, and we're very, very good at that. If you want to know exactly what was blocked and who inside your network got blocked by it, that's not something we can provide because we don't store any of the information about that. We don't store information about your end users. So again, if you're looking for that, we advise that you put a forwarding cache at the edge of your network and you implement those kind of solutions in that. If you're looking for advanced versions of that, then we'll forward you to someone like IBM or Cisco or one of our other threat intelligence providers. That's typically what the business customers are looking for. ISPs potentially are looking for less of that. Individuals are typically looking for that on a very, very limited basis. They're not particularly interested in knowing what threats they've had. They're interested in having them stopped, and that's really all they care about. We're not an antivirus program, so we can only block on DNS. We can't base our blocks on any kind of full URL path or any kind of binary examination. It's just DNS. Right now we're in 146 locations. I'm going to get in a little bit more of the technical details. We're in 88 nations, and I think we added one since I put this slide together. I think we added Burkina Faso 2 days ago. So we're constantly expanding. Right now we are located primarily with Packet Clearinghouse. Again, they're another not-for-profit, but we're expanding that footprint into other hosting providers as well as into ISPs who are interested in hosting our services. One of the things I want to talk about a little bit today is how Quad 9 differs because of our IX model versus a transit model. Again, I mentioned that we're in SOCs right now. So to give you an example, we have most of our traffic delivered to us via direct or one-hop direct peering versus buying transit. So because we're at IX locations, we have a significant amount of interconnections with all of the members of the IXs, especially if there's a route server. Again, that's kind of the model here in Serbia. We find that keeping the traffic local, keeping it in country makes a big difference. If you're buying transit, often your traffic will go out of the country boundaries, which exposes it to potentially interception or at least observation by third parties. We're really trying to keep the traffic as local as possible to the end users, therefore we're distributing it at the IX locations. The advantages there are the space and power for IX locations are often, if not as good as, better than hosting providers or ISPs where there is sometimes less stable network conditions. Some of the downsides with the IX model are that in certain countries where there are large monopolies or semi-monopolies, it's very difficult to get IX interconnections at no cost. They'll demand transit pricing. In other words, they'll try to force us to buy transit. So there are some countries where we have poor connectivity. The one that keeps coming to mind is Australia. I'm not sure if any of you know anything about Australia, but there are a few incumbents there that don't peer at all. So our traffic from Sydney for about 40% of the user population will actually go to either Singapore or Los Angeles, Singapore or Los Angeles. Most countries, however, have a very robust IX structure. So this works out, as I said, for about 80% of our traffic right now is directly peered, and only about 20% is transit. We have, I think, 12 different cities now worldwide that are in the transit model. Here's actually a snapshot of SOCs. This is what percentage breakdowns look like for traffic that we are transmitting across the IX in city. So this was actually a very interesting one because we had a very large ISP convert over to us. That blue section represents their forwarding recursive resolvers turning on overnight. You can see exactly when they turned on. So they're now the majority of our traffic. But then there are about 30 other ASs that are sending us traffic here in at the SOCs. We track statistics on per AS basis, so we can tell how many queries are coming from an AS, but we don't actually track the queries themselves. I can't tell you that a particular query came from a particular AS or a particular IP address because we don't track any of that data. A little bit about our peering and network. As I said, we're mostly with PCH. AS42 is our transit provider or our hosting provider for the network. Again, because they're a not-for-profit, they have the same goals as we do. We also provide, if you're an ISP or a network service provider, we can provide you with an instance to put inside your network. So this is something that's relatively new for us. If you have a large enough customer base who has an interest in Quad 9, or if you have an interest in deploying Quad 9, we can deliver an instance to you either at a low cost or at no cost, where we put a one-use server in your network to keep traffic even more local. We can provide also some minimal reporting on that as well, really just volume counts. So if you don't want to run Recursive Resolver yourself, Quad 9 can do that for you. Depending on the circumstances, there's either a very small fee, $200 or $300 US, or there's no fee, depending on whether you can provide us transit or not. What do we use? We are entirely open source based, but we are entirely redundant. In fact, we're sometimes triply redundant. All of our platforms right now use a combination of PowerDNS Recursor, Unbound, and Bind. Actually, PowerDNS Recursor and Unbound take most of the queries. Bind right now we're using just for ECS. We'll probably expand that in the future. All of these are both load shedding and load sharing. So any one of them, you have a random chance of getting any one of the two. And then if one has a fault, you'll automatically be converted to the other. This has actually saved us on a number of occasions where we found bugs in one of the two packages that have caused outright faults. But for the user community, they didn't notice because we automatically fail over to the other. Inside of each location, we operate multiple servers. Those are virtual servers in some cases and physical servers in others. So we use ECMP to just deliver the traffic across those multiple servers. So we're redundant at the software layer, meaning the recursive resolver layer. We're redundant at the virtual machine or the machine layer or and the hardware layer. And then we're using Anycast so that even if an entire city is taken offline, queries will automatically get routed through BGP to the next available city. So to this point, we've had 100% availability from a global perspective. There have been local outages, but those are typically things like somebody accidentally routes inside their network 9.9 or 9.000/8. And those are typically quickly resolved because user community complains and fixes the issue. And then we're running also, sorry, I forgot to mention this, we're running CentOS and Ubuntu as well. So in case there's a security or a reliability problem in either one of those two, we have redundancy at that level. So it's extremely difficult for the network to be rendered unavailable due to problems. And the way that we solve the other issue, I think there's going to be a discussion a little bit about DDoS, is that by increasing the number of locations and having a large amount of transit volume, that's really the only effective way to solve the DDoS problem at scale, is you simply have to be bigger than it. You can't ultimately fix DDoS. You have to simply absorb it. So by increasing the scale of the network and increasing the number of sites, that's the primary way that we solve DDoS. There are, of course, a number of other techniques that we can use to absorb the DDoS at the DNS server level, where we sometimes will absorb connections, not respond to them, or convert to TCP. And that's that's a talk in itself. Finally, how can you help or how can you participate? So we're constantly looking for partners who can provide us new threat intelligence information. That's our primary value proposition for most people, is the threat intelligence. We are looking for additional partners for sponsorship. We are not for profit. We do get contributions from individual users, but primarily our contributions are from people in the threat intelligence community, in the financial services area, and in the general internet stability world. So we're looking for additional sponsors in that area. And then researchers, we are open to having research projects using whatever the data is that we do collect. the anonymized or I guess the no PII data. Some people find that extremely interesting for research projects in university and internet studies area. And then, if you operate a CDN, get our egress IP address list so users don't have to use ECS, because ECS is pretty terrible. And I think that wraps it up. Thank you.
Thank you, John. We heard another interesting story about public DNS, and next presentation is Cloudflare .1.1.1.1. And Henry will be presenting in agenda. It is Max, but Max couldn't make it, and we'll have Henry right now.
Thank you so much. Yeah, so another presentation about DNS, and thanks, John. We will also, just like John, at the end talk about DDoS a little bit. For us, that has a much more important role than for Quad 9, because in contrast to Quad 9, we do a lot of things related to performance and security, and not just DNS. Very quickly, if you look at my badge, it says Maxime. My name's actually Henry. I've been with Cloudflare for a few years, and I'm currently based in London after being in San Francisco for a while, helping the company launch new products. So whenever we bring something out, like 1.1.1 or now Magic Transit, and I'll explain what that means in a moment, I'll help make it successful, whatever that means. If you want to get in touch, feel free to send me an email. It's just hh@. It's very simple. Yeah, so before I actually talk about what we're doing with regards to DNS or DDoS, if you have never heard of Cloudflare before, this is sort of the one slide that's kind of the one you should not forget. And it's actually, ironically, quite similar to what John showed with Quad 9, which shows, that either one of us is onto something here. So we have a pretty large, globally distributed network. We are also in Belgrade with SOCs as well. So it's really important to us to be as globally distributed as possible. And one important thing is that each of these locations, each of these cities that you see here, the data centers that we have there fulfill more than just one function. So it's not like we have a DDoS data center or a DNS resolving data center. They all do exactly the same thing. And we'll see why that's important in a moment. So let's start with the DNS portion. So we also have a DNS resolver, right? And like Google and like Quad 9, we like easy numbers. So we got 1.1.1, which is great because it's very easy to remember. But it's also a problem for reasons that we'll go through in a moment. But yeah, our main focus when we built this was privacy. And right now, today, just a few numbers. It's currently doing about 150 billion queries per day. And the graph you see here is actually from when we launched it. So basically, we launched it on the 1st of April, 2018, so about a year and a half ago, and immediately had a lot of people using it. But we also had a lot of noise, and we'll see why that's interesting in a bit, because the reason that this IP address 1.1.1 wasn't in use before is not because it doesn't exist or because it's unallocated or unassigned, but simply because the people that owned it, Appnik, chose not to do anything with it because they couldn't really, right? There was so much bogus traffic coming in, they couldn't really do anything. So they basically agreed with us at Cloudflare that they would give us access to this IP space in exchange for some joint research programs, which they couldn't run because they literally just were not able to use it. And again, that's why this large network that I showed you is really important. Without it, this would effectively not be possible for us, right? So for someone like Quad 9, it might be possible to do this today, but if you're just starting from scratch, right, like if you're an ISP somewhere, then this is not going to work. But yeah, as you can see, our sort of goals were speed, privacy, and research. So we'll start with the research aspect. You might be wondering, why would anyone want to use 1.1.1? Right, it's a DNS resolver now, like, this is like, what else would you do with it? Well, it turns out a surprisingly large number of people for years have been telling other people that they should use this because apparently it's fictitious and unassigned, right? That is, like, neither of those statements are true. It's very real, and it's definitely not undersigned. It was simply private, right? There's a big difference between the two. So this is, I think this is the CCNA documentation, right, which is like the Bible for network admins. Even they said use 1.1.1 for testing purposes. What could go wrong, right? Nothing. There's lots of other people doing that, like no need to shame on anyone. And just ask yourself, I'll give the answer in a bit, how much noise do you think we get, right? We'll come back to that question in a moment. But yeah, basically, these are some examples. I know it's quite small, but the day we launched, we noticed how much pollution that IP space really gets, right? And actually, all of the names on the left are the good ones, right? So these are all the providers we came across who were not actually doing this properly, right? They had some misconfiguration, but due to a lot of user reports, I think John mentioned something like that earlier, and the hard work of those providers themselves, we got in touch with them, they cleaned it, it's all good, right? No problem. You guys all did great. Don't want to go into details why this was the case before, right? No one's fault, but it's fixed now. There's even an example here with Sonatel, that's the one I highlighted, where they blocked, or where they were using 1.1.0/8, but not 1.0, and so forth. So actually our secondary address, 1.0.0.1, was working fine, but 1.1.1.1 wasn't. Users reported it, we got in touch, and as you can see, from one day to another, the black line was 1.0.0.1, and the orange one was 1.1.1.1. From one day to another, it started working, which is great. But it gets worse. It's not just the backbones that were doing this, that were polluting the space, but it's also CPEs, right? Like consumer routers you would have at home that were sending strange signals, or even, I think, some printers that were using 1.1.1 for reasons that we don't know. So with the help of RIPE, we actually did some kind of expedition to hunt all of these devices down. It's a never-ending search, but I think we've done a pretty good job over the last year and a bit. There's actually a really good blog post on our website on how we used a lot of RIPE probes to find all of these devices step by step. But yeah, the answer to your question is about 10 gigs per second of noise, and about 10% at the beginning at least. This has changed over time. So this slide is about a year old. So about a year ago, it was around 10% was legitimate traffic, right? So that's not a lot, which is why AppNic didn't do anything with this IP space before, because it would have literally just burned their servers down, right? And you see most of the traffic we get is HTTP traffic, not DNS, as it should be. But yeah, let's go to the privacy aspect, which is a lot more interesting. The reason why we built this was not to like sort of, I mean, one of the reasons we built it is because we could, like we were able to do it, which is great. But the other reason was that we said, and that was discussed earlier by both John and David, that there's a bit of a privacy issue with DNS. So a lot of that's already been said, so I'm not going to go into too much detail here. But we basically set out to implement a lot of things that we thought would make the internet better, right? That's sort of our mission as a company, is to help build a better internet. And we wanted to implement all of these things. So one thing that John just talked about was the ECS situation, right? We don't want to leak that into the world. There's some other things that I'll go into in a moment. But sort of the most important thing is what you see here on the right, which is we will not store any of your information, right? So similar as Quad 9, we're not storing any IPs, ever, right? We just don't. No one can access them. We do store a few data points, but not client IPs or anything like that, which will then be aggregated and shared with AppNic. All of these logs are also deleted within 24 hours. So if for some reason the US government, and we are a US-based company, right, full transparency, decides to invade our servers because they saw something that they don't like, they would have to do it literally within 24 hours, and even then they basically don't get a lot. So yeah, we're really, really strict on this policy. There's no one who has access to anything effectively. But yeah, let's talk about a few things that we're doing specifically to improve privacy. One thing we're doing quite aggressively is Dns Query Minimization, because effectively the qualified name that typical resolvers send out is pretty long, right? And if you go to the root resolver or the .com resolver, they don't actually have to know half of the information that you want, right? They just have to know the next little bit that's relevant to the respective query. So we are basically taking the query apart and only asking the next question, so to speak, and then taking that answer to go to the next resolver and so forth, right? That's the whole point of being recursive. But instead of giving everyone everything, we only give them what they need to know. Then the other thing, and I know it's been talked about extensively, we've partnered with Firefox for DoH implementation. I hope everyone now knows what DoH is. Thanks, David. And there's been a lot of controversy around it, but I think the fact that it is a possibility to set it up and that you have the choice to do this in an easy way is pretty important. And we can debate around, positive and negatives around that. But I think that we are making it more accessible to users is a step in the right direction. Another thing that I didn't actually put on the slide, I'm not sure why I forgot, but we also actually have a mobile app which allows to configure 1.1.1 at the press of a button, and it does work on iOS. So you can totally set up 1.1.1 if you think that we're trustworthy on your Apple devices. So we're trying to make this whole thing more accessible and more user-friendly. If you don't trust us, right, that's your choice. Like, I'm not going to try and convince you. But if you do trust us, then you can set this up quite easily. The final part is speed, right? It's quite important, so I put this little table on the right. Cloudflare is fundamentally, apart from being a security company, also a performance company. And from the start, it's been really important for us to make it very fast. There's a couple of things that we're doing. I put up 2 of them here. One of them is very aggressive pre-filling. So we use things like the Alexa 1 million, Umbrella 1 million, and a few other databases to figure out what are the most popular websites in any given region. And then we aggressively cache those sites so that the first time, even if we haven't cached it, quote unquote, before a customer or user goes onto these sites, they will immediately get a response. The other thing we're doing is backend multicasting. So we're sharing the cache effectively across our machines, because as our network size grows, this becomes a real issue, right? And then the other thing, which may or may not be really obvious, but as I said earlier, all of these little dots do a lot of things, not just resolving DNS. For example, they're also authoritative DNS servers. We have about 20 million websites running on Cloudflare, and almost all of them use Cloudflare as an authoritative provider, meaning these are the servers that actually hold the answer to your DNS questions. So if the recursive, like if the person asking the question and the person giving the answer are in the same room, obviously everything happens a lot faster. So the more customers we have with websites on our site, the faster we will be able to resolve that for everyone using 1.1.1. So it kind of benefits both sides, right? We get more people using the resolver. That's great for people with the website. We get more people using the websites. It's great for people using the resolver. And then obviously, similar as with Quad 9, right, the more locations we have around the world, the better, right? We can answer things faster. Ooh, there we go. So in summary, really easy IP. That's great. We're focusing a lot on privacy. We had, some issues with old devices polluting the space, and it's quite fast. And finally, we think this is sort of one further step in the right direction of improving how the internet works. But unlike Quad 9, sorry, I keep referencing you, but there are a lot of similarities. But this is where things kind of go apart. We're not a charity, right? We're not doing things for free. Although this particular service is free, at the end of the day, we have to make money somehow, right? Because we're certainly not getting free money from PCH or IBM and so forth. So one of the things that we're doing is we're selling our network for DDoS mitigation. And that's sort of the next topic that I'm kind of squeezing into this one talk here. Whoops, skip the slide. So we have a product called Magic Transit, which is pretty new. Personally, the name is a little confusing, but it's going to make a lot of sense, right? In a moment. What we're effectively doing with this is we're providing DDoS mitigation for data centers. So someone running an ISP, for example, I have a feeling there's 1 or 2 people in the room doing that, could benefit from this by protecting the entire network and not just proxying HTTP applications. So in the past, and I'm sorry, this is a little bit salesy, but I'll make it very short. In the past, if you wanted to protect your network stack, your on-premise equipment from DDoS attacks, you would have to buy a lot of these really expensive appliances, right? It's a huge upfront cost. They're very specific point solutions. If you have a specific problem, right, you get a specific appliance, you get a specific machine. And after a couple of years, they are basically outdated and you have to get new ones, right? So it's not great. And we have this great buzzword, digital transformation, right? Stuff is moving from being on-premise into the cloud. And in this case, it's not just, a buzzword, we're not just using this metaphorically, but that's actually what we want to do, right? We want to have this transition where we take things that are typically inside a data center, hardware things, and instead use virtual network functions to accomplish exactly the same thing. That's sort of the whole idea. How are we doing this? Basically, again, this map sort of keeps coming up, but basically, we have this huge network, right? We have a resolver, we have a CDN, we have a web application firewall, all of this stuff. But if someone attacks Cloudflare's network and brings Cloudflare down, our resolver is offline, right? No one can use 11111. That would suck, right? Everyone using this for their DNS would be stranded or maybe has to rely on their backup. So we have to figure out a way to protect our own network. And we basically had a choice at one point to buy these appliances, right? There's lots of vendors selling these appliances. We thought about buying them ourselves, putting them into our own stack, into our data centers, securing us this way. But we figured actually it would be a lot smarter if we just use commodity hardware and our own software stack to basically build this solution from scratch, which is exactly what we did. And that's effectively now what we're offering everyone who's interested, right? So we're offering the power of Cloudflare's entire network, right? About, I think, 194, 200-ish scrubbing centers at the same time, which can protect whatever we put behind it. That's sort of the whole premise. Might still sound a little ominous, but we'll get through it. What we're doing is kind of something that you might already have seen if you're familiar with DDoS protection, and I know after this we have a lot of ISPs and telcos talking about this in more detail, so you probably know exactly what I'm talking about here. We would announce, the customer's IP space via BGP. So now all the traffic is going through us. And then inside this orange cloud, we would do, someone described it as a washing machine, right? We wash the traffic, we scrub it, take out all the dirt, take out all the attack traffic, and then we forward all of the clean traffic. And this is where it gets interesting, because Gre tunnels are, pretty old, right? It's not a new concept at all. But what's interesting is we're doing Gre tunnels via anycast. So that means we don't actually have, one point to connecting another point, right, where we connect to a scrubbing data center and then that scrubbing data center connects to the final destination. But in fact, we have 200 scrubbing centers at the same time. And the way that works is effectively like this. We found out that Gre is stateless, right? So it doesn't actually matter that we have different devices or machines. It's just connecting IP addresses. And the packets that are sent from an IP to another IP are just being sent independently. So it's completely irrelevant that we have 200 separate locations, right? They're just sending packets, and it doesn't matter, if we call it a tunnel. It's more like a conduit or something like that, right? We just send things, and it's definitely not point-to-point. So this way, we can constantly announce your traffic around the world and keep forwarding all of the traffic to your destination without slowing the traffic down in any way, because again, we have 200 data centers, so we're pretty close to wherever the eyeball, wherever the click is coming from. And what actually happens inside is quite interesting. It's a little bit small, but we'll go through it maybe very quickly. Basically, some vendors say they have 0 time to mitigate, right? That's sort of our first step. Basically, that's where normal rules kick in. If you block an IP, right, if that IP sends a packet, we can just block it. Takes no time, basically. Very simple. Then we have our edge routers, which do some basic mitigation. That takes about 10 seconds. So if you have a lot of traffic, and it is possible to have false positives here. I've got some negative feedback yesterday, but we're obviously trying to reduce them as much as we can. But this is sort of, where most of the work is happening. If we see an attack, that's usually where it gets stopped. At the same time, we're constantly sending NetFlow or SFlow data to a core data center where we apply some machine learning on the traffic flows that we see. And if there's more complex attacks that we didn't immediately spot, we will send feedback to our edge routers. They will implement these new rules and start blocking on those rules as well. So that process takes about 1 to 5 minutes, depending on the complexity of the attack. And then finally, far on the right, we have a SOC. So if we completely fail at everything horrifically, which obviously never happens, then you can give the SOC a call, and they will manually take a look at the traffic and mitigate it. So that's sort of very briefly how Cloudflare DDoS mitigation works on the inside. An example, Wikipedia, a few months was attacked by a DDoS attack. And we did something that we have never done and we don't really intend to repeat. We did an under-attack onboarding while they were still being attacked. We onboarded their prefixes within a few hours and started announcing the entirety of their traffic globally. So you can see here, we announced a slightly more specific route to their IP addresses and inserted our AS effectively in front of theirs, meaning the traffic would now hit us where we could perform the scrubbing as explained before. And then send all of the clean traffic to Wikipedia via these Anycast Gre tunnels. And again, talking about the Anycast Gre tunnels, the really interesting thing here, and that's why we call it magic transit, is that it basically doesn't affect latency at all, right? So 3 milliseconds for an always-on scrubbing solution is pretty low. And this is actually a global average, so in Europe and North America, it's close to 0. So yeah. In the middle, by the way, you see the spikes. That was when the attack happened, right? So obviously the latency went way up, which is, I guess, why they gave us a call. So yeah, in summary, we can do this Gre over Anycast solution, which is pretty cool because it means that we no longer have to slow traffic down in order to protect it, right? So that's kind of our core mission, is to provide security without degrading performance. Then overall, we're trying to achieve this paradigm shift, which is to move away from sort of a CapEx model where you pay a lot of money up front to a model where you can just pay as you go, right, OpEx, and you reduce your total cost of ownership of the whole situation. And then finally, because we do not just offer these layer 3 network type protections, but also layer 4 and layer 7 application-specific things, we can actually just tack these on top of what you have in your network, start, for example, proxying your HTTP applications, offering some further firewall services on top of that at the click of a button, right? We can deploy these network functions without much effort. So that's sort of that. Again, if you have any questions around this, if you want to learn more, feel free to get in touch. And otherwise, I think we're going to have a roundtable now, talk more about DNS, and then I think after that, more about DDoS. So this is great.
Thank you, Henry. You can take your seat, and I'll call John and David to join you. Publika ima dosta pitanja. Možete i vi da počnete, mogu i ja da pitam naše goste, kako god. Javite se, samo dignite ruku ako hoćete. Okay, that was a short introduction. What we are going to talk. All three of you were talking about DNS, and first we had David, who had a really interesting presentation in regard of DoT and DoH. And I would like to ask you two about Quad 9 and Quad 1, about implementation of DoH, and do you have any measurements how much it is used and by whom?
What were the questions on measurements? Yeah, so I don't have any numbers off the top of my head. I don't actually think we've published any numbers publicly on adoption. I know that apart from the Firefox users, it's not very high. And the reason for that is kind of what we discussed earlier. If you don't know what you're doing, which is the majority of the population, then it's really hard to set this up. So, for example, you can go on the Cloudflare website and read the guide on how to set up DoH. It's not trivial, right? It's actually pretty complicated unless you're using Firefox or using Chrome. So the percentage of people using it is still quite low, I would say. I don't know, maybe you have.
Yeah, but I have one comment, because first version of Firefox, everybody started talking, was, do you want to be secure? Yes, and all traffic goes to your DNS servers. Did you see that peak and...
Sorry, yeah, so actually, when this was first introduced, it was only running on the nightly version of Firefox. So there was no crazy spike of DoH just going up, because it was just the beta version, or I think it's not even the beta version, it's the alpha version, right? So it's the nightly build where it was first introduced. And then that's when all of the backlash happened, right? So people were like, oh my God, you are rerouting all of our DNS traffic through this American company that we've never heard of. This is not good. When in fact, like, it was very much a choice, right? I don't know what percentage of Firefox users use the nightly build. I would estimate it's less than a full percentage point. So there was no real spike, but the backlash was pretty heavy. And before it was actually rolled out publicly, they added all of these changes, right? Whereby you can now choose your DoH provider. You can go into Firefox and say, I don't actually want to use Cloudflare for as my DoH provider. I want to use Google, or I want to use Quad9 or someone else, right? So before they actually rolled it out to the proper full build version, they made a lot of changes, which I think is quite sensible.
Okay, thank you.
So right now for percentages, just because I was looking at this the other day, for DoH, we're looking at less than 1% of our traffic right now is DoH. And I think slightly more than 1% is DoT. But those numbers are growing both very quickly. We're looking at probably around a 10% to 12% growth per week right now in both. But they're still very low numbers. DoT has been growing quite quickly because of Android, because of the automatic conversion. If you're using, if you get in your DHCP server, if 9.9.9.9 is handed out, there's automatically a probe which will try to convert over to DoH or DoT automatically. And so that's actually been bumping the numbers very steadily for quite some time on DoT. DoH has been not as large, and I think that that's going to change, of course, when the default behavior of Firefox becomes DoH. And what really is going to change it is the Windows conversion, but I think we're still looking at quite a bit of time before that occurs. The vast majority of traffic right now is unencrypted. 98% plus is unencrypted. I don't expect that to change overnight, but it won't be overnight, but it will take several months. If both Chrome and Firefox, and also I know Opera is also considering it, although they're a very small percentage. But if the browsers start to change over and they require DoH, then we'll see this happen relatively quickly. And that, I think, is one of the concerns, is that, it's not overnight, meaning it's not literally overnight, but over the course of a couple of months, we could see the majority of DNS queries going from unencrypted to encrypted, because most people are now on automated updates for their browsers. And if the browser includes it, then it's going to happen. And it's, the decisions of a very small number of software shops are going to influence significantly data flows and potentially policy worldwide. And that's one of the things that makes everybody nervous about these protocols, I think.
Yeah, that's true. I would like to ask David, because most of the articles talking about DoH and DoT are complaining about aggregation of DNS queries to big players like Quad9, Quad1, Google. We have announcement of, that Apple is going to build their DNS infrastructure. Also, Microsoft a couple of days ago. What is the bigger issue than aggregation to few big players? Because personally, I believe to big players, and I don't think they are going to do any funny stuff. So maybe one day, because if we are talking about commercial issues, maybe it will change. But can you explain a little bit more about application doing DNS and how dangerous is that? So if I make application and I point that to my DNS server, I can do whatever I want. I can tweak root servers, I can tweak DNSSEC, actually remove DNSSEC stuff at all, and resolve DNS queries the way I want.
Yeah, I mean, again, it's about unintended consequences. If what John talks about comes true, and then a year from now we're sitting here at the 6th edition of RSNOG, and the majority of DNS traffic is encrypted to the recursive resolver, I'd like to think that's a good thing. I'd like to think that's good for our users. But DNS is a funny thing. It's just this little protocol that fundamentally hasn't changed that much in 34 years.
I think even,
Yeah, but it's one of the most important things in the entire world of the internet. When you're an application maker and you're spawning you're spawning like a Chromium browser inside the application, like, if you're on Reddit, a lot of folks use, and it spawns a browser. We don't know what the browser is. We don't know much about it. We don't know what it's doing. And the sites that it's taking us to, we're not able to verify just by looking at it that it's the actual site that the domain owner intended. And so more than just a function of DoH and DoT is just the overall concept that DNS can be abused by unscrupulous application makers in a way that we've never really thought of before, and our users certainly aren't going to like. It's an industry issue for everybody. DoH and DoT is simply bringing these more to the forefront than we've talked about before. But it's funny because you can do it. You don't need DoH or DoT to do what these parade of horribles, these nightmare scenarios we think about. You can actually just do that with DNS out of the box.
That's true, I can, but it can be tracked if it is encrypted and sent over the network, and especially our HTTPS network. It is very difficult and hard to block that. 854 is port which is used only for DNS, so we can track where DNS queries are heading. We don't know what those queries are. But which HTTPS, as you mentioned, we don't know is that DNS query or it is just HTTPS traffic. And yesterday we discussed a little bit what and where we are heading, because I don't believe that many countries, let's mention China and Great Firewall, will appreciate what's going on with DNS. And many other countries will just follow, and I believe we'll have some kind of fragmentation of the internet. What do you think?
Well, I think, first of all, it's really interesting that the main contribution, I feel like, of DoH and DoT is that people are now talking about DNS, right? Because, as you said before, you could, hijack DNS. You could, have root leaks and stuff like that. Nobody cared, right? Because no one understand it. They still don't understand it, but now they're like, oh, someone is encrypting this thing that I didn't understand, so now I can't even try to understand anymore because it's just gone, right? Which is cool. It's maybe a little too late now, but at least people are now talking about it and seeing it as an issue. So I think, to your point, right, if more countries start to do things like China and start to block things, we talked about Euronet before, which was a proposed idea of having sort of a great firewall, but for Europe, like these types of things, as they're now being discussed, people will take more seriously and won't just say, oh, you're talking about this thing I don't understand, like, yeah, whatever. But in fact, people will look at it and say, oh, actually, you are fundamentally messing with everything I do on the internet. Maybe we should take a step back, even if I don't understand it, invite some experts, explain this to me, and then we can have a real debate about it. So I think it's a positive change in that regard. I think there's a question way back who's very enthusiastic.
Yeah. Thank you. So I want to ask you, about Cloudflare. You say in your slides that you like don't log IP with 1.1.1.
Right.
And then like three sentences down is like we delete logs every 2 days. So what gets logged?
Yeah, so if you go on our website, there's a very specific list of things that we do log. So in some specific cases, we will log query names, for example, but they will not be associated to a user. It will just say, we've, you know...
Just a request.
Right, so like 1 million people have opened this website. We don't know who they are or where they're coming from, but this website's like been queried a lot of times. One of the main reasons to do that, and I think John talked about it briefly earlier, it's not just the whole compliance thing, but also for debugging, right? If we completely throw away everything and something breaks, like we will never know that it's broken. So that's the main reason we do that. But again, on our website, there's a very detailed list of what we keep for these 24 hours.
Thank you.
Oh, you're welcome.
To go back to your question about, you know, what are the bad things that are occurring and how is this happening, I'll try to summarize kind of at least my personal opinion on how DoH is at best neutral. You know, we supply DoH, we provide DoH in a centralized way. At the same time, I'm not sure that it's necessarily a good thing. It provides encryption. I think everybody on this board and pretty much everybody everywhere agrees that encryption, being able to provide protection from interception or rewrite, is a good thing, no matter how it's done. The problem is that DoH does it in a way that accelerates the cat and mouse game between people who are trying to maliciously, or I shouldn't say maliciously, it pits the end user against a network operator. And because DoH now means that the network operator who used to control the DNS server doesn't, and they can't even see what the transactions are. And ultimately, that's going to lead to a power struggle between end users and network operators. In many cases, the end user is going to win, meaning that their encryption strategy will work and no one will interfere with it because there isn't enough money or staff or desire by the network operator to interfere with the query stream or to examine it. However, I also believe that in a large number of cases, the network operator is going to win. They're going to say, well, okay, if every browser is now a VPN, we're disconnecting you all from the internet. And that everybody now has to go through a proxy in order to get to the internet. You know, your clever encryption model isn't going to work because there is no longer end-to-end connectivity. And so for some people it's going to improve conditions, and I believe for some people ultimately over time it's going to make conditions worse. We are headed in this direction anyway. DoH is simply an acceleration of the process. It is not the cause of this process, but it's a thing that is going to push that user versus network operator conflict much more quickly towards an end that may not be good for everyone.
David, you do not have a comment on that. Okay, thank you, and I agree. Encryption is good stuff, and both HTTPS and DoH and DoT are good, but how we can control the way how it is implemented? You know, in my opinion, it is great if, for example, we have the example of Firefox just pointing to .1.1.1.1. Now we had choose. So if I have DoH enabled resolver and people can choose that, that's the main point, that we have choice. The danger is that that can be hidden into application, and the application can do some funny stuff. Actually, not application, but application can point to DNS resolvers, which can do funny stuff and resolve DNS queries the way maybe malicious owner of them wants to do. Okay, are there other questions?
Hello. I would like to ask people from Quad 9 and Cloudflare, do you use DoT when your resolvers are contacting authoritative name server? Do you think that there is a point or use case for setting DoT or encrypted communications right on the source of the information? Do people in Cloudflare, where they have thousands and thousands authoritative zones on their name servers, do you use DoT on your authoritative name servers?
So the answer to that is that, I'll go kind of in backwards order. For Quad 9, we believe, yes, that is a very important aspect of the DNS that is currently not standardized. There is a working group on that. There are some pre-standards attempts already underway to get authoritative, like as an example, Facebook right now is running DoT for their authoritative servers. We believe, Quad 9 believes that that is an excellent next step to get the authoritative to recursive encrypted. We're waiting for a standards-based method to do that. And I think everybody, and I won't speak for Cloudflare, I'll let them speak, but I think everybody in the space, everybody in the recursive resolver space is very interested in that. It's the last unencrypted leg. And so yes, we are working towards that. To end users, that doesn't mean much. But between enterprise or ISPs and authoritative servers, it means quite a bit, because it's that typically the cross-national borders is where your DNS is being observed, and that's typically between the recursive resolver and the authoritative resolver is where that is occurring. So I think that that's an aggressively pursued model.
Yeah, I think Cloudflare is very much in the same boat, although we are in a very unique position, right? Because we do provide sort of both sides of the equation. And typically, not just for DNS, but kind of all like new standards that are being developed, we're pretty actively involved in not only developing the standards itself, so I know members of our team are on that DoH working group, etc., like trying to draft out the RFCs for that. And then what we quite often do in our dashboard is that we provide these new protocols or new options even before they're standardized. So we will have, for example, we had TLS 1.3 available for our customers even before it was an approved standard, right? Obviously with the caveat saying, look, this is not completely finalized yet, but we try to push things out even before they're standardized. And now you can sort of, judge us or mistrust us for trying to influence the way that standards are being implemented, but that's sort of our approach to kind of pursuing that avenue.
I'm not going to give an answer. I'm actually going to ask you a question. It's an honest question. For a network operator who actually runs their own recursive service for all of their users, why is it good to encrypt the queries and responses between that recursive resolver and the authoritative? Philosophically, why is it good? There's no end user IP, there shouldn't be end user IP information being sent. It's simply asking, hey, give me the next authoritative server down the chain. It doesn't impact the users. What's the privacy concern? Why is it good?
Well, if you're using ECS, there is some component. But even without ECS, by raising the difficulty level of intercepting anything, you increase security for everything as well. So just by pushing that floor up and making all DNS encrypted, it becomes less unusual to have DNS encrypted, right? And it also increases the level of effort so that somebody who is trying to do interception has to cast a much wider net to figure out what's going on. So that's an obvious answer. There are probably many more, but that's one that comes to mind immediately.
Yeah, but may I add one question? Because we're talking about privacy, and HTTPS header consists of address as well. And looking just address and looking the size of the packet, we can pretty much be sure in guessing where it is actually. We know where it goes and from where we are getting that packet. But looking just at size, we can guess what page or what query went there.
I'll take a couple of things on that. So from the DNS perspective, there's padding. So DNS queries can be padded, and I know Cloudflare does that. We're actually waiting for some patches to do that on Quad 9. So you can insert information into the DNS query that more or less disguises what the DNS query was involved with when it's encrypted. Second of all, there's SNI encryption that is coming. So when you connect to an HTTPS server, a portion of your, a lot of people don't know this, and it's always surprising to me how many people don't know it. When you connect to an HTTPS server, the first part of your connection is unencrypted, and it includes the name of the server to which you are trying to connect. So even if the IP address is on a CDN that hosts thousands of different content objects, someone looking at your network traffic can tell what you're trying to get to, or at least they can tell the host that you're trying to get to. SNI encryption is coming. That's another one of those very aggressive things, and I think that's I want to say that's a fallout from Edward Snowden, but I'm not sure. But being able to encrypt the SNI component, and then the last thing I'll add is that the HTTPS transaction is well outside of anything that the DNS providers can solve, and so that's really the W3C and other people who are going to have to fix HTTPS content determination based on fingerprinting. That's a whole other working group that has to solve those problems.
Okay, thank you. And David, you didn't answer. Actually, I asked DNS providers, but I know that Paul Hoffman is doing some measurements for ICANN. Do you have that numbers, or it is still ongoing?
Yeah, we haven't published yet.
And you cannot tell us? Okay, thanks.
Okay, one more question. Two more questions, actually. The first one, quite easy, I suppose. If lawful interception comes and asks for a key, will you provide? Decryption key.
Decryption key for HTTPS?
Yes.
So, okay, difficult answer there. So we will obey the law as it applies to us. And if the law does not apply to us, or if we can put legal barriers in the way, we will do that. So I cannot say that we will not abide by the law, right? That's not something we can do.
Of course.
So if there's a legal requirement for us to provide a key, we will. We have never been asked for that, and I suspect we never will. And I can tell you that I will give you a hint that we're looking at policy methods of solving that problem at a higher layer, and we'll have more news on that in the next 5 or 6 months. Okay. But that's, I suppose under some circumstances, yes, we would have to, but I can't imagine what those circumstances would be, because that would be a very, very big deal. And the repercussions from that would be more significant than I can imagine any investigation would be worth.
Mm-hmm.
Yeah, to add to that, to Cloudflare, obviously we're also US-based. We are very aggressively fighting any national security letter that comes in. So typically in the United States, the government can send basically secret letters to a company and say, you have to give us this information and you must never talk about it. We have and we will continue to completely ignore that and publish all of these letters. So if we are ever being forced to do that, we will tell people. We've never been forced to do it. We have a bunch of canaries on our website basically saying we have never done X, and then should we ever secretly be forced to do that, then we can remove those like negative statements. But yeah, I agree with John, like if the government decides to do that, that basically disrupts how everyone is doing everything, right? And I can't imagine they would want to do that. Apart from that, I mean, and that's Cloudflare specific, we have a couple of technologies that we've built whereby customers can retain control over their keys without putting them onto Cloudflare infrastructure, but giving us access to those keys through a couple of encrypted channels. It's very interesting if you want to read about cryptography. It's called keyless. You can read up about it on Cloudflare. So that gives some sort of extra protection, but obviously if the government wanted to breach that, then they probably could, right? They have guns and we don't, so at the end of the day, they can do whatever they want, in theory.
Okay, I asked the question because simply the choice of DNS provider is a trust issue. and they will trust you, but they are not sure that they will trust, let's say, man in the middle. That is, you hold the keys, and you could be trusted or not trusted. And the second question, unfortunately, man from Cisco left. He claims that DNS service works well independently on the latency. Like, okay, the DNS server is not in Serbia, so what? It's in Romania, it's in Hungary, it's 10 milliseconds away. What is your standpoint? Obviously, you put 200 servers all around the world trying to decrease the latency. Is the latency crucial or not?
Right, I mean, so what we always say is we're trying to fight the speed of light, right? Like the only thing that we can't change is the speed of light. We can't impact that. So literally the only thing we can do to make it faster, right, if we already have fiber, is to physically be closer, right? So the more points of presence we have, the better the service will be, right? And I mean, there's a reason that Cloudflare has close to 200 of these presences, and Quad 9 is, you know, catching up, and Google, I don't know how many they have, right? And same for Cisco. There's a reason they're doing that, and that's just performance. So yeah, absolutely. I think if anyone can build their own DNS resolver, right? Like, it's not that hard. There's software for it on the internet. But if I only have one server and I put my resolver on that and that's it, and then I start traveling around the world, like, my internet will be really, really slow. So yeah, absolutely. I think it's quite important.
We spoke about the security issues, like my data will not leave the rack, and that is okay. But I'm asking about the performance, the latency.
Sure. So there was actually a paper that was just released within the last 2 months on this very topic. And I'm sorry I don't remember who wrote it, but I think some keywords would bring it up for you. And the net of that was that, yes, it does make a difference, but not as much as you might think. That 15 milliseconds or so of difference doesn't make that much difference on a page load, on a web page load, but if you start moving it out, it starts to get noticeable in a minor way, and that's because of the large number of non-cacheable objects in a lot of advertising networks that they force a lookup that goes all the way back to the authoritative server for, you know, web bugs and things like that. But it did not seem to make much of a difference. You know, plus or minus 15 milliseconds was not noticeable. And I'm sorry I don't remember the details on the paper, but it was a...
No, okay, but 15 milliseconds, it's like 1,500 kilometers.
It's quite a distance, yeah. So I mean, but again, there's loss and there's latency, and then there's actually the latency of the lookup itself. So there's not just the latency between the network component, but there's, once a query reaches a recursive resolver, how long does it take to get an answer back from the authoritatives? And that's actually just as much a significant issue as the latency to the recursive. So it's cache size and everything else has a lot to play in that.
Je li ima još neko pitanje iz publike, pošto smo malo preterali ovog puta, da, ušli smo u ručak. Thank you very much. We have to stop. If somebody has a question, you're available for questions of audience.